So we need to factor this polynomial here, and we notice that it's not a coefficient 1 problem, that there are 5t squared here. But luckily this 5 goes in to all of the other values, so we have a GCF. So we're going to start by taking 5 out of everything. If I divide everything by 5, I've got 5t squared plus 3t minus 10. Alright, so the GCF of 5 has been factored out. Now, however, this right here, this trinomial, can be factored further. So let's go ahead and factor that polynomial by breaking down the negative 10. It's negative, so we're going to need to have one positive and one negative. And we want them to add to a positive, so the positive is going to be the larger value. So it goes into 10, we have 2 and 5 go into 10, and we know that the larger value needs to be the positive to get a positive 3. So this is going to factor into, bring down your 5 times t minus 2 and t plus 5. That's going to be completely factored. So we factored this twice, actually. The first time we factored it was by taking the GCF of 5 out, and then it was by breaking the trinomial with coefficient 1 down into 2 parentheses using the last term c and splitting it into two numbers that added to b. Let's try something similar on the next problem. Okay, the next problem appears to have a typo. Let me get that fixed. Alright, there we go. The problem right here should have had an x squared. So there's a little bit of typo right there. Let's look at this new version. Okay, so in this problem, the first thing I notice is that it's not in the right order at all. So I'm going to start by reordering it in descending order. So that would be 3 cubed So we're talking about this problem right here, and we noticed that it wasn't in the right form to factor right away because there's a coefficient in front of the squared term. So I can't break into two parentheses directly. But I do notice that everything can be divided by 5, namely there's a GCF here. That was the kind of factoring from section 1. So let's go ahead and take that 5 out. If I divide it out, I'm left with t squared plus 3t minus 10. So we've factored it by taking out the GCF. Now we're going to be able to factor the trinomial again, looking at the negative 10 as the last number. It's negative, so we're going to have one positive and one negative. The middle term is positive, which means the positive term needs to be the largest. And 2 and 5 make 10. Positive largest will make this a negative 2 and a negative 5, which add up to a positive 3. So this will factor into, just drop your 5 down, into t minus 2 times t plus 5. So the final answer is 5 times t minus 2 times t plus 5. So there were two factorings. We had to first factor out the GCF, then we factor the trinomial further into two parentheses. Alright, now this next problem over here, you'll notice there was a typo if you had the course pack. So I had to rewrite this. There was supposed to be a squared on that last digit right there. So I went ahead and rewrote that there, and I'm just going to cross that back off. Okay. So this is not ready to be factored quite yet either, because first of all, it's in the wrong order. Let's go ahead and rewrite it in descending order. Be 3x cubed minus 30x squared plus 75x. And then there's a GCF here again. I can take out a 3 and an x from everything. That would leave me with x squared minus 10x plus 25. Okay, so we factored it once, but I think it can be factored again, so let's try. Let's take the 25. It's positive, so when I want two of the same, they're both going to have to be negative. So negative 5 and negative 5 go into 25, and they add up to a negative 10, which is what I need, so that's perfect. So when I factor this, just bring the 3x down. It's 3x times x minus 5 times x minus 5. Okay, so that would be our complete factorization. Now you can write that as 3x times x minus 5 squared, because I've got the same factor twice. You could write it that way as well if you choose. Either one of those would be correct. So again, I factored twice, factoring out a greatest common factor first, then factoring the trinomial into 2 parentheses by breaking down the last term. That trinomial had coefficient 1, so we're in the last term, and then separated it into 2 terms, added to the negative 10, and multiplied to the 25. Alright? Now, in all of these that we've tried here, we have been able to factor them. Okay? When a result cannot be factored further, it's completely factored. Notice I had to do 2 steps here. Factoring out the GCF wasn't enough. There was more I could do, so I've got to make sure it's completely factored. But sometimes we're going to get to a polynomial that can't be factored. If you can't factor something, we call it prime. Just like prime numbers, like 11, can't be factored into whole number products. If a polynomial can't be factored, you will call it prime. All right. And for an example of that, let's consider the polynomial x squared plus 3x plus 2, for example. If I look at, no, I made one that could be factored. I didn't do too good on my sample here. Let me try a 4 there. Okay, so if I try 4, let's see. The only things that go into 4, it's going to have to be 2 positives, are 4 and 1, and that adds to 5, which is not what I want. 2 and 2, and that adds to 4, which is also not what I want. There's nothing else that multiplies to 4. 4 and 1, 2 and 2 is it, and I can't make 3, so this one right here that I wrote was prime. That would be how I would answer if I was asked to factor something that I could not factor.